We run the city.
Today's agenda, got the suitcase up in the central. Go to room 112, tell them Blanco sent you. Feel the strangers, if no money exchanges. I got these kids in ranges to leave them niggas brainless.
Hello! Welcome back to Making Games Poorly, the show where I take a good game and remake it as quickly and lazily as possible. Last week, we went and took a look at a little indie game called Pong. Today, by viewer request, just the one, we're making Snake, but with corgis and snacks. Corgnake. Whatever. Snake, as you know from most Nokia phones, is a game where you play as a streak of pixels eating other pixels and growing. And, well, that's about it. You just get the fruit and don't hit the wall. The special part of today's episode is going to be the algorithm for Snake movement, because I think it's simple yet super clever and just... Anyway, you're going to want to make some assets in Photoshop. You can make them better than I did. In this case, I have a 192 pixel wide, 64 pixel tall sprite sheet of a fat little Corgo. Yeah, it's pretty bad. I also grabbed a 32 by 32 pixel sprite from the internet, so credits to whomst ever made this. Slice up your sprite into 3 separate chunks for later, and away we go! Oh, one last thing. I've included the source code and assets in the description if you want to use it to follow along. Start off by creating a project and changing the size of the main camera to 10 and adding some walls to keep in the Corgnake. All they need to have is a simple 2D box collider attached. Try and keep them precise by using exact coordinates if you want. Assuming you've pre-sliced up your sprite sheet, drag in the head, and put a little box collider on it. I changed the size of the box to 80% of the original so that the head and body don't accidentally collide. Create a Corgnake controller script, and in the start function call the invoke repeating function. Pass in a method name, a time, and a repeat rate, both floats. Basically what this does is it executes a function for X amount of seconds every Y seconds. We're calling this to get pixel-perfect staggered movement. We could rig up something with a rigid body on a normal fixed update, but I feel like that would be way more complicated and definitely not worth it. Create your move function, and inside of it, translate the position of the player based on a certain direction. On a nit, we'll just say that old Corgo is going right. Test it out to make sure it works. This is where things get potentially a little scary if you're a new programmer. First, we want to use the Unity link library in order to utilize lists, so make sure to import it at the top of your script. What is a list? Well, in C# at least, it is a variable-sized generic collection of information. This makes it perfect for our Snake game because we might be adding many body segments to our Corgi, but we don't exactly know how many. So we're going to make a list. This is going to be a list of transforms, basically just a series of positions we're going to manipulate. I called mine long body because, hey man, this body could get pretty long. In your move function, create a variable to store your current position. It's an XY coordinate, so we need a vector too. Also, we have to set up some stuff before we can do our algorithm, so create an onTriggerEnter2D function to detect if we're snacking or smacking a wall. Make a boolean to detect whether or not we've recently had a gentle snack. If you hit the snack, you eat the snack. Make sure you initialize it false because we're not eating anything right now, you dummy. Create a game object to hold your body prefab for maximum thickness. Alright, so we're ready to get this algorithm going. The first thing we're going to do is handle what happens when you eat the snack. Create a variable to hold onto your body prefab, and instantiate it at position V when you eat. After instantiation, make sure you set the hasEaten variable to false, or else you'll get an infinite body spawn. Next, we're going to handle the case of our list being greater than 0. This is the meat and potatoes. This is the juice. It's a super simple algorithm, only 3 lines, but it works really well, and it's super clever. See, when I embarked on this journey, my stupid ass was like, okay, Snake, I need to get bigger when I eat. This means I need to add to my length and also shift every element of the body forwards X amount of pixels. Okay, but how do I handle turning? How do I translate it? How do I get the elements to work together well? It was frustrating to say the least. So, I turned to Google. How goody! Yeah, whatever. Okay. So for full transparency, this is not mine. I did not create this. I don't know who did, but I saw it on this website. The point is understanding the mechanism behind the movement. So how do we do this? How do we handle turns and move the whole body and make it work well? We don't. All we ever care about is the position of the last element in the list and the current position of the player. Set the position of the last element of the list to the variable that you assign to the transform in the beginning of the function. In my case, it's v. Longbody.insert takes an index and an item, so you want it to be the first element of the list, 0, and longbody.last is the item, transform, to add. Then, just remove the item from the end of the list and boom! You're done. Also, make sure when you instantiate a longbody addition, you actually insert the game object's transform to the list. Tee-hee. Here's a little step-by-step. Make a game object for your body prefab. Put a collider on it just in case you run into yourself, and drag it onto your script. Test it out, make sure you got a growing Corgo, and boom boom bow, boom bow, boom, skip it bow! You did the thing. Woo! This next little bit is bog standard. On your update function, add some conditionals to change your movement vector based on the player input. Now, we have pretty much what we need as far as player movement and mechanics go. It's time to handle the rest of the administrative things. Score, menu, spawning snacks. So, you know what time it is. It's time for Game Manager! Make a new script and let's go to town. Add the transform of your walls so you can reference their position in order to contain the snacks within the boundaries of the level. Create a pop snack function to spawn your snacks. Create a position variable to store a random position within the boundaries of the grid. This is kind of verbose, but it's basically the position of the wall plus or minus 1 on the x or y axis. Here's a little diagram. Instantiate the snack at the position you picked and then increment the amount of snacks on the grid. Create a variable for the current amount of snacks you have and the maximum amount of snacks you want. In the start function, create a for loop and add the snacks you want, and in your update function, check how many snacks you have against how many you should have, and pop a new snack when you need to. Next, make a decrement snacks function for your player script to call when it destroys a snack. Again, I don't know if this is the best way to do this, but it's a way. In your Corgnake controller script, create a new private game object for your game manager. Go down to the trigger enter and find the game manager object so you can reference the game manager script and call the decrement snacks function. This was the easiest way I thought to keep track of the snacks, but there may be a less roundabout way. Oh, make sure the decrement snacks function is public. Side note, I've heard that using the find method to search by tag is kinda slow and may not be the most optimal method, so it may be fine for this use case, but not so good for others. Drag your snack prefab onto the game manager and test her out. The snacks should never fall below 10 because when you eat one, you should decrement the snacks, and then the update will find it's less than max, and pop one off. Real quick, let's reference the Corgi's sprite renderer so we can flip the sprite based on player input. In the game manager script, let's create a game over function that we'll make use of later, and then add an init game function to call when we want to reset the game, or start it up. Check to see if the user is playing on update, and if not, check to see if the user presses 1. If they do, initialize the game. If they press 2, quit the application. Create a bool to store your playing variable and a score int to keep track of, well, you know. Create a game object for your player prefab and a holder variable for it. In your init function, set your score and snacks to 0. Pop the snacks and instantiate the Corgo in the center of the screen. Set playing to true, and back in your game over function, set it to false. This next part is a little weird. Create an empty array of game objects for your snacks and your Corgi body additions. The reason we need to do this is we have to set the variable to the array of objects you have, loop over the array, and destroy each item. It's been long enough since I recorded the screen for this episode that I don't remember why I did this, but I remember for some reason not being able to delete every item without looping over the objects and deleting them individually. So use find game objects with tag to add the objects to an array, use for each to loop over them, and make sure the prefabs have the correct tags. The next bit is boring UI stuff, basically just setting and displaying text at the correct times and making sure the score is updated. The one notable thing being that in your controller script, in any trigger collision that's not a snack, call the game over function. After that, add in some sound effects when you're partaking a gentle snack, and some music for the game, and ka-chow! Corgnake! Make the background green to simulate a realistic backyard, and then export it, and you've got a game! It's a real game! It works! Ha ha ha! Side note, at the time of recording I couldn't figure out how to get the butt to follow and was too lazy to look. So here's a code snippet for the butt. Make a butt prefab, drag it onto your controller, and update your move function with this, and you got a butt. So what now? Well, the game looks like a steaming pile of ass. If you'd like to expand, you could add all sorts of things. Mega snacks, better art, rotate the sprite renderer correctly on player input. But hey, this is making games poorly, and this seems like a pretty crappy game. Mission accomplished.
Hello! So that was Making Games Poorly, Episode 2. Thank you for sticking around to the end. If you, or somebody you know, would like to request a game that I make poorly and show you how to do, leave it in the comment section below. Also, if you like it, give me a share. Give me a little like, subscribe. Tell your friends, tell your family, tell your mom. Stay tuned for Episode 3, because it's gonna be a banger. I just know it's gonna be good. You're gonna fucking like it. It's just gonna be the best. It's just gonna be the best. Tell your friends, tell your family. And we'll see you next week.